Hello to my lovely Algebra 2 with Trig students. I'm sorry that I can't be there with you today, but I've recorded this video to help make sure that we stay on track with the notes that we need to do in Unit 4. So at this point, you should have already completed your Tuesday warm-ups, so these problems 1 through 8. So make sure that you have those done at this time, and then you can go ahead and take out your notes and turn to day 2. If you have not had time to finish your warm-ups, then you can pause this video until most everybody's done with the warm-ups, and then when you're ready to move on to your day 2 notes, you can press play again. Okay, so moving on to our day 2 notes, this is on page 3 out of your notes packet. We're talking about solving quadratic equations by graphing. And so as we do this, we're going to once again use our graphing calculators like we did yesterday. So you want to have that out and ready to go. So before we get started, let's talk about how we have some different terms that are used to talk about the same thing. So several terms that are all equivalent, they mean exactly the same thing, are solutions, zeros, roots, if you spell it right, R-O-O-T-S, and x-intercepts. Okay, all of these things mean the same thing, and what they mean is that they are the places where the graph crosses the x-axis. Okay, so since we're talking about a parabola, we know the shape looks like this U shape. Okay, so depending on where that is graphed, you could have 3 different options. You could have one real solution, okay, and that's going to happen. Here, I'll draw a picture for you. That's going to happen if your graph is just going to come down and it's just going to barely touch that x-axis. Okay, so that means that it intersects it just one time. Okay, and so going back up and filling in the line above, a quadratic equation can have 1, 2, or 0 real solutions. Okay, so once is when it just crosses, or not even really crosses, it just touches that axis one time. So then it could have 2 real solutions if we come draw an axis over here, okay? If it actually crosses and goes down below and then comes back up above, okay? So here's our 2 real solutions, and so there it's intersecting the x-axis twice. Okay, and then of course it could also be happening where it's upside down the other way. And then it would just look like this. Okay, still crossing the x-axis twice, so 2 real solutions. And then a graph could have no real solutions. For that to happen, here's our axes, then it would just be like somewhere up here above the x-axis and pointing up, or it could be down below the x-axis and pointing down. Okay, so that would be that a graph with no real solutions never intersects the x-axis. So these are our 3 options. So what we want to do is we want to today talk about how to solve this by graphing. Later on in this unit, we're going to talk about how to do it using factoring, which I know we all love, as well as completing the square and the quadratic formula that we mentioned yesterday. But today, we're going to do it by graphing. So first thing we want to do is create a table of values, okay? Now, you can use your graphing calculator once again to do this, or you can just do it by hand by figuring out where that axis of symmetry is. If you do it by hand, that's where you use that formula x equals negative b over 2a. Okay? So if you're doing it with your graphing calculator, then you would take out your graphing calculator and go to your y equals and type that into the equation. Okay? So let me get my graphing calculator out. Now, you'll notice your equation looks a little bit different today because it has that 0 equals. Don't let that stress you out. When we type it into our calculator, we're just going to treat that 0 like a y equals, okay? Now we do want to make sure it's a 0, and we'll talk about that a little more on number 2. But for now, we'll just assume that that's a y equals, and we're going to type that into our graphing calculator. Just like we did yesterday, y'all. Nothing different here. Okay, when I look at my graph, it looks like my y-intercept, my vertex is at -2. So I'm going to go to my table, and remember I do that by hitting second graph, and that takes me to the table. And so if I look at -2, I see that the y value there is -1, and then that my points mirror on either side of that. So from -1 going up this way, it goes to 0 and 3, and then the same thing down the other direction. So I'm just going to fill in those x and y values. Okay. You also could have done this and found this axis of symmetry using the formula up here if you wanted to. Okay. So now I'm just going to graph those. And I'm going to sketch that curve, trying to make it curvy and also trying to make sure that it goes through all of those points. And here I'm just looking for the spots where it actually crosses the graph. Okay, so these are called my solutions. And so that happens here and here. Those solutions are x equals -3 and x equals -1. Okay. You could also sometimes see it written in the brackets, x equals that bracket, -3, comma, -1. Either one of those answers is acceptable. Okay. All right, so at this point you've seen one example. If you need to pause this video and go back and watch this example again, you can do this. This video is also available for you on YouTube, so in your own time, if you wanted to go back and watch this, you could do that as well. So we're going to go down to number 2, and once again we're going to graph this in our graphing calculator. So the first thing we want to do though is we want to make sure that we have a 0 equals right here, which obviously we don't because we have that 2. So how do we get that 2, get rid of that 2 or move it to the other side? We would subtract it, right? So if I subtract 2 over here, then now I would have that 0 equals x squared minus 4x, and now it would be a plus 6. Excuse me. And so here, now we are doing the same thing with our graphing calculator. We're going to type it in to our y equals. So typing in that x squared. Here, let's see if I can show you what it looks like in case you need a refresher. Okay, so here's my graphing calculator. Try not to get you too woozy. So we're going to y equals and typing in that equation, which I've forgotten now. Okay, it was x squared minus 4x plus 6. So here we go, x squared minus 4x and plus 6. Okay. Okay, so they're looking at this graph, it's never crossing that x-axis, okay? And fill in the table and whatnot. So we'll go to second graph, and we'll look at our table here. So let's see, I'm going to go this way. And now I can see that it goes from 6 down to 3 down to 2, and then it starts going back up to 3 and then to 6, okay? So now I'm going to go back to my notes, and I want to fill that in my table. So my axis of symmetry there was at 2, 2. And so I just want to fill in the points that happen just right before and right after that. Okay, and then of course graphing it. Okay, sketching in that curve. And so here we can see that there are no solutions. Okay, Specifically, there's no real solutions. Okay, later we'll find out that there might actually be some imaginary solutions there, and so we'll talk about that later on. But as far as we're able to tell on the graph, there are no real solutions. Okay? All right, so now moving on to the next page. Now we're really going to talk about how you can find this on your graphing calculator, because sometimes our graph doesn't cross at these pretty spots, okay? Like if we look at number 1 back up here, it crossed perfectly at -3 and perfectly at -1. However, sometimes it might cross at -1.256, blah, 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 okay? So when that happens, we're going to use our graphing calculator, and our graphing calculator is going to tell us exactly where it's crossing. So you are going to need a graphing calculator for this. If you don't have one, look on with somebody else and kind of take turns putting this in your graphing calculator to make sure you know how to follow the steps. I'm not going to just read you all the steps right now. You can see them right here at the top of page 4, but I will walk you through those as we go through our next example, okay? Okay, so number 3, x squared equals 0. So to do this, we are going to, once again, go to our graphing calculator, clear out anything that was in there, and type in x squared, okay? When we graph it, and you may already know the answer here, okay, it's going to cross right here at 0, or it's going to touch the axis there. You can go to your table to see the different points that happen. We've got one at -2, 4. We've got a point at -1, 1, at 1, 1, and at 2, 4. Okay, so you've got space down here to write down both of your solutions if you have both of them. In this case, you only have one, so your only solution is x equals 0. Okay. All right, the next example, number 4. First thing we want to do is fix the fact that we've got a -3 over there. So add that 3 to each side, and we end up with 0 equals x squared plus 4x plus 1. Okay, I'm going to go to my graphing calculator and graph that. And so I'll show you once again. Let's see, that was x squared plus 4x plus 1. So going to my graphing calculator. Okay, I want to hit y equals and clear out what was there. It was x squared plus 4x plus 1. Let me double check and make sure that was right. Yep, x squared plus 4x plus 1. And so now as I graph it, okay, so I can see that my zeros, or my solutions, look like they're happening at 0 and -4. So I want to check that using the table on my graph. So I'm going to hit second table. And remember, I'm looking for the place where our y value should be 0. Okay? So if I look at, it looked like 0, right? But my y value there, when x equals 0, is actually 1. Okay? So let's go to -4. Okay? Same thing at -4. It looked like at -4, my graph crossed and the y value should be 0 there. Okay? Looks like it. But now that we kind of look a little more closely, we can see it's really not exactly 4. So when this happens, when it's not crossing at one of those pretty numbers, we're going to use our graphing calculator to find the zeros there, okay? And you're going to use the same steps that were given to you right up here at the top of page 4, okay? So at this point, we have already put the equation in the y equals, okay, form. We put it into our calculator. We looked at the graph, okay, and we want to estimate where those zeros are, okay? So let's scroll back down here, and our estimate, okay, is that it's around -4 and 0, okay? And I'm going to put that little squiggly there, okay, showing that it is approximately -4 and 0. So now we're going to use our calculator to actually find the exact value, okay? Now you've got the steps here. I'm going to try to walk you through real slowly, but go back over here so you can see what I'm doing. So I want to go to my graph, okay? And from my graph, I want to hit second trace, okay? Well, what are we trying to find? We said it's called a 0, so that's our second option right there. I'm sorry that my camera keeps moving around so much, okay? So we want to choose that second option. Sorry, trying to make it where you can see it a little better. Oh, that's not working. There we go. Okay, this is what we chose. I think maybe I've messed up now. Let's try it again. Second trace, and then we want to choose option 2, 0, okay? So when you do that, it's going to ask you for a left bound and for a right bound, okay? So first one is a left bound. So I want to find where my graph is crossing this point right here, right around -4. So what I do is I go and I hover right around where that 0 is, and then I tab over to the left a little bit. I'm just using this left arrow, okay? So now I'm a little bit to the left of that 0, and I hit enter, okay? You couldn't see me do it, but I hit enter down here, okay? And now it changed to saying right bound. So now I want to use my right arrow and I want to scroll just past where this 1, 0 is, okay? We're only worried about one of them right now. And once I get past it, I want to hit enter again. Then it asks me to guess, okay? So I'm going to scroll back and try to hover over where that 0 is, okay? I can't get right on it, but I'm going to hover close to it. And then I hit enter. And now my calculator is telling me exactly what that 0 is. And so it's -3.732, okay? So go back to my notes over here. And that first 0 was happening at x equals -3.732, okay? Okay, so if I put that on my graph, it's going to be somewhere around right there, okay? So now I'm going to go do the same thing for the other 0, okay? If you have 2 zeros, you have to do this process twice, okay? So let me swap back to my camera. Okay, get it where you can see it. All right, so here I want to do the same thing, but this time finding the 0 that is right around there, okay? All right, so to do that, I once again go second trace, and I have this calculate menu, okay? From there, I want to choose option 2, which is a 0. And remember, this time I'm doing the one that's over here on the right side, close to 0, okay? So I'm going to go over close to it. I went a little too far. There we go. Go over close to that, okay? And I want to go to the left of that 0. So I'm using my left arrow, and I'm tabbing over a few times, maybe 2 or 3 times, and then I'm hitting enter. That is my left boundary. See that little arrow pops up showing the boundary. Now I want to do my right boundary. So I'm going to tab back to where I'm over the 0 and then a few more times. So now I'm to the right of it and I hit enter. Okay. And now it says guess. So I want to go back to where I'm just hovering right over that 0, hit enter, and now it tells me what my 0 is. It's -0.26, and that actually rounds up to an 8 because it was 7.9. So -0.268 is my 0. So going back to my notes, x equals -0.268. Okay, so that is my other intercept, or my other solution, my other 0. They're all the same thing, okay? So I can go and put that right there. And so now if I just kind of sketch my graph, okay, I know that, let's see, -2, -3 is one of my, that's my vertex. I'm just looking back at my table and that's what's telling me where I'm graphing these. Okay. So there's our 2 solutions, and we've got them written right down here. Okay. All right. If you need to see that again, pause this video, rewind, and go back to that. Okay. But you're going to see another example right here on number 5. Okay, so now number 5, I'm going to go to my y equals, and I want to type in my equation. Now, wait a minute. There's a problem with this equation. We got to get it in that 0 equals form. So what I want to do is move the x squared over to the other side, which makes it positive. So x squared plus 4x plus 2. Oops, made a mistake, y'all. Sorry. Should be x squared minus 4x plus 2. Okay, make sure you fix that. X squared minus 4x plus 2. Okay, and so I'm going to type this into my calculator. X squared minus 4x plus 2. I'm putting that in the y equals. And I'll walk you through this as I do it. Okay, there we go. And so now I want to hit graph. Okay, and so now that I graph it, I can kind of guesstimate where my zeros are. Okay, it looks like one of them is happening between 0 and 1, and the other one is happening, let's see, 1, 2, between 3 and 4. Okay, so let me go ahead and write that down over here. So my estimate, okay, is that it's happening between 0 to 1, and then another one we said is happening between 3 to 4. Okay, so if you want to go ahead and graph it, you can use your table. Okay, and I'm going to go down to 0, x equals 0, and it tells me I have a point at 2. At 1, I'm at negative 1, 0.1, negative 1, and then 2, negative 2. And then when I go to 3, it's at negative 1, and at 4, it pops back up to 2. So now I can see my graph looks something like this. Might be helpful to graph it like that first so you have it on your paper. Okay, and so my zeros, here we are. We can kind of estimate where they are, but we want to find the exact. Okay, so to find the exact, we're going to walk through the same process again. Okay, so that process was go to your graph, and then we want to hit second trace. So second, and then this trace button brings me that calculate menu, and I want to do a 0, that's number 2. So you can either scroll down or you can just hit 2. Okay, so for the first one, I want to hover over that first 0, okay, just doing 1 0 at a time, and left bounds mean that I go to the left of it. So just tab to the left 1 or 2 times and hit enter. Right bound means I go to the right of it. So here I am back right around that 0, and I'm going to hit the right arrow maybe 2 or 3 times and then hit enter. Now we can see that boundary there. And then guess, I go back and hover over where that 0 is. I'm pretty close right now. Okay, and there we go. So my 0 happens at 0.588. Okay, 0.588 was that 0. Okay, all right, one more time for my other 0. Okay, let me actually show you another way you can kind of do this. So still going second trace. Okay, selecting that second option, 0. And going over here, hovering over that 0 that I know where it is. I just got to figure out the exact, okay? All right, so I want to go a little bit to the left of it, okay? So once again, you can tab over if you want, okay, a few times and hit enter. Or another option is if I know it's between 3 and 4, I can tell for sure that this one is between 3 and 4, then my left boundary would be 3. I could choose 3 for my left boundary and hit enter. Okay, and now my right boundary, I know it's somewhere before I get to 4. So for my right boundary, I could type in 4 and hit enter. Okay, and so now I have those boundary marks. For guess, I'm going to scroll back and hover over it. Okay, and then I'm going to hit enter. And there it gives me my 0, 3.414. Okay. 3.414 was my other 0. Okay, so there gives you some options. Okay, you can either use your little arrows to the left and right to tab over, or if you already can tell that it's between 3 and 4, you could just type in a 3, enter, and then type in a 4, enter. Okay, you could have also done that on the other problems that we did. Okay, all right, so that is how you use your graphing calculator to find the solutions. Okay. So now we have a little bit more to do in our notes, The next part asks you to summarize what you've learned, okay? We can skip that for now since I wasn't there to work with you. And once again, if you need to go back and once again see how to do any of these examples, just pause the video, rewind it, and watch it again, or you can do it on your own by looking up this YouTube video, okay? Okay, so the next thing that you're going to do, and you're going to do this in your groups, or if you'd like to do it by yourself, you can, but I would recommend working with some other people to be able to bounce some ideas off of each other, is that we want to look at what happens when we transform these quadratic functions, okay? Meaning that we move them around on the graph, okay? So to do that, we're going to explore this, what's called the vertex form, okay? And that's given to you right here. F of x equals a times x minus h squared plus k, okay? So your goal in this activity is to examine how changing any of those values, a, h, or k, will transform the graph of the parent function, okay? The parent function is like our original, that x squared, okay? That's just our basic parabola. So we're going to look at what happens if we do that, okay? Now you can use your graphing calculator. That's what I would recommend. You could also graph it by hand if you want, but I would recommend using your graphing calculator, okay? So first thing you want to do is, or as you do each of these, you want to highlight them in different colors, or you could use different colored pencils, okay? You can, and I'll go ahead and place some of those colored pencils at the back of the room if you need to borrow some of mine. Just make sure that you put them back where they belong when you're done, okay? All right, and so then you're going to graph it, and whether you graph it by hand or your graphing calculator, make sure that you also graph it on the page that we're working on, and sketching that graph, labeling it with the function, and then we're going to record the vertex as well as answer some of the follow-up questions, okay? All right, so here we go. Number one, we'll do this one together, and then I'll give you some time to do the others on your own or with your groups. Okay, so first I'm going to start by graphing just the basic parent function. So in my graphing calculator, I'm going to type in x squared, okay? And I'm going to hit graph. Okay, so you with your graphing calculator, show you the camera. Okay, you're going to y equals, typing in that x squared, and then hitting graph, okay? This is just your basic one. I would leave that one in there the whole time you do this activity so that you can compare back to it and see what it looks like, okay? All right, so the next one that they wanted us to graph was 1/2 x squared, okay? So now we can actually graph two of these at the same time so that you can see both of them. Ooh, isn't that so cool? So to do that, we go back to our y equals, and this time don't delete out what's in there. Scroll down, okay, and go to your y2, and here's where we're going to type in that 1/2, 1 divided by 2, x squared, okay? You could have also typed in 0.5 if you wanted, okay? So I can either hit graph and I can watch what happens, or if I want to really be able to see which one is which, then I'm going to tab over to the left all the way back here till I'm hovering over this little slanted line. So right now it's going to graph the two of these with the same line, okay? But if I hit enter, now it's going to make that second one thicker. So that might be cool so that I can see the difference between the two. So I just hit enter one time so that I would see that thicker line. And now when I hit graph, okay, watch what happens, okay? So that was y equals 1/2. So what I'm seeing is that it makes it fatter, or makes it wider, okay? So let me go back here. My vertex, I can just see from looking at it, is still the same. So my vertex is at 0, 0, okay? All right, and when I graph it, I'm just going to kind of come over here and sketch it, okay? All right. On some of the others, you probably want to actually plot some points there, okay? But for time's sake, for now, I'm just going to sketch it there. All right, so then the other one, y equals 2x. So now, let me go back to my camera. Okay, there we go. So we're going to go back to our y equals, okay? Now, you can just replace the y2 that you just had, or you can go all the way down to y3, and we can type in 2x squared. Almost forgot my squared. And remember that this is our third graph, so if you want, you can go back here and you can hit enter. Now it's going to make it thick, or if I hit enter one more time, that would be for inequalities. We don't want either one of those. But I think there's a way to do one on here where, oh, yep, there it is, dashed, okay? So if you want, you could do it dashed. And so now if we go to graph, it's going to graph that one. We can see that dashed line there, okay? And so we can see that if we do y equals 2x squared, it's going to make it skinnier. So my vertex, once again, was 0, 0, okay? So what was the value of a in f of x equals x squared? Well, it was just 1. So the effect of changing it to 1/2 was that it made the graph wider, okay? Whereas if we change it to 2, it made the graph skinnier. Okay, or more narrow if you wanted to maybe use some more mathematical terms, okay? So you're going to go through this process in your groups. Oh, and almost one more thing, I almost forgot to graph my last parabola right here in the middle, making it more narrow, okay? So like I said, sorry, my Apple Pencil died, so we're doing the best we can here. So a little bit messy, but there we go. We can basically get the gist of what we're doing. Notice how I did them in different colors so I could see the difference between the two, and I would go over and highlight or shade over which one is which so that you can tell which one's which, okay? So at this point, what you're going to do is you're going to continue through and you're going to do number 2, and you're going to do the others on this page, number 3, 4, and 5, okay? And hopefully this will help you see how changing those things affects your graph, okay? Number 6 is for you to do for homework, okay? And so hopefully at the end of this activity, you'll be able to tell just from looking at the equation what that graph is going to look like, at least being able to estimate it, okay? So the last thing I have to leave you with is to make sure that you finish this transformations activity, and this is on page 5 and 6 of your notes. And then make sure you do your homework for tonight. That's Unit 4, Day 2 homework. And so that's the homework out of the notes, as well as finishing this homework, or this problem 6 out of your notes from today. Okay? All right, I hope y'all have a great day, and if you have any questions, feel free to text me on Remind, and I should be able to reply during the day today. Sorry I couldn't be there with you, but I'll see you again tomorrow. Bye!